Hi guys, we're going to do a few homework examples from lesson 3.5. The two problems I've picked out are number 26 and number 30 from the first section, which says use an end behavior diagram. You're either going to draw a figure of up, up, or down, down, or up to the left and down to the right, or down to the left and up to the right to describe the end behavior of a graph of each function. Do not use a calculator. Because this first equation has a cubic as its exponent, that means we have to remember what the graph of a cubic looked like. Okay, because the parent of a cubic took this kind of shape, it was like our snake graph. It went down to the left and up to the right. Because it's a cubic and it has a negative sign in front of it, that means there's a reflection across the x-axis. So this little section over here will go up, and this section down here will go down, and you will end up with the snake going the other direction. Well, that would be this guy right here, which is going to be up to the left and down to the right. And notice that we're not connecting this because we don't know what's going to happen in the middle. Okay, we only know the ends of it. We don't know what's going to happen in the middle. On number 30, because this time you're dealing with an even function, all even functions are going to resemble the graph of x squared, which we know is a parabola. For this particular one, the leading coefficient is positive, so the arrows are up and up. This one also is positive. Because it is positive, we're going to have the same characteristics as the original parabola. We just don't know what's going to happen in the middle. So this one again is up to the left and up to the right. And again, we don't connect it because we don't know what's in the middle for this one. And that's number 26 and number 30. Now I'm going to bump it over to numbers 42, 44, 46, and 48. There are 4 equations up here. They go with 4 graphs. We don't know which equation goes with which. They're all kind of mixed up. It says number 42, which graph is that of y equals x to the 4th plus 7x to the 3rd minus 5x squared minus 75x? Because this is x to the 4th and the leading coefficient is positive, that means that we're similar to a parabola, the actual parent of the parabola, which goes up, up. The only graph that has arrows going up and up is part B, choice B. It's the only one it could be. Everything else is up and down, even part A, down and up. So that couldn't be number 42. Number 44, the graph of y equals negative x to the 3rd power plus 9x squared minus 27x plus 17 is either C or D. Which is it? All right, so if we start off with the concept of what we just learned a second ago, it's got to be the snake graph turned upside down. Since the parent graph normally goes down to the left and up to the right, the reflection will be up to the left and down to the right in this direction. C and D, up, down, up, down. Both of them have those same characteristics, so we got to look at something else that we know. There is a rule that says if you have an exponent of 3, you can have at most 2 local extrema. The local extrema are those spots where there's a switch in the graph from going increasing to decreasing. This is a local extrema. This is a local extrema. Local extrema, local extrema, local extrema. When we get to here, it looks like there's not much of any local extremas going on. So that kind of fits the rule. The rule says at most there can be 1 less than your highest exponent, which would be 2 in this case. Over here, this has 1, 2, 3, 4 local extrema. Because it has 4, it doesn't fit the rule. It says you can have at most 1 less than your degree. So the only one that fits that situation is choice C. Now, 46. How many positive, and that's the key word there, positive real zeros does the function graphed in D have? D, positive. Well, you have the x-axis here. Here's 0. This way would be negative. To the right would be positive. So how many times does the graph touch the x-axis? 1, 2. and it crosses completely through it. I want to remind you that if it bounces off, that counts as 2 zeros that are exactly the same. But this goes all the way through for 1 and all the way through for 2. So there are 2 real zeros for part D. And number 48 is the absolute minimum. Is the absolute minimum value of the function graphed in B a positive number or a negative number? Absolute means it's as far down, because it says minimum, as far down as it can possibly go. For this particular graph, this right here is the absolute minimum. So we're just asked to look at the up and down values, which are your y values, because high would give you absolute max, low would give you absolute minimum. Since we're in the negative numbers down here for y, around negative 100, the answer to this one has to be negative. And that concludes our homework help for lesson 3.5.